as a modeling tool. And so my first point is, for this presentation, I'm going to keep it really short. I didn't actually prepare it for, I was thinking there was going to be a screen, but so I could show you, step through it a little bit better, but I think it's going to be great. If you want to talk to me later, so I can show you some of the things I'm going to just mention during my brief, like little 5-minute talk here, I'm happy to show you if you're interested. The point of my presentation was really just to communicate to practicing CAs kind of what kinds of different ways you can use CBECC-Res modeling, not just for compliance, but ways to help you visualize models, understand what's going on under the hood, do other kinds of analyses for zero net energy, just unlocking it. So before, like, we're used to using these modeling tools and it says pass or fail. We can do better, and I think we will be doing better for our clients. And I'm just wanted to, because it's not well documented in the software itself, we can. I was going to show you a few tricks that I've done. The first thing I was going to show, but I'm just going to mention, is how to unlock the sort of developer settings research mode that were also mentioned yesterday in the water heating section. So that's the first step to, like, opening up all these new menus. I'm like, oh, I didn't know CBECC-Res could do load calcs. Sweet, you know? So I can show you that. There's lots of stuff that you can play around with there. And including things, just to drop a few details, like you want to change the framing factor on the walls. You can do that when you unlock some of these options. You can also include different thermostat files and just do the stuff that really energy consultants should be doing as a value to their clients to really understand, like, deeper energy efficiency retrofits or upgrades to new construction, but that code compliance tools lock for you. They don't let you really analyze that stuff for compliance. So second topic I was going to show was actually how I visualize my results really easily using a free software from NREL. And you can see kind of a pretty graph of sorts that's really easy to make. And
Which slide are you on there?
This is on, yeah. Topic 2, visualizing results. You've got the site energy. I've got this. The slide I'm showing is actually visualizing the impact of the TDV multipliers on, in terms of the impact for compliance. You can see, like, oh, the utility, the grid or energy commission cares about maybe 200 hours out of the year, which is where us mortals who pay energy bills, we care about all hours of the year. So, and being able to visualize that in my mind kind of shows that discrepancy, as well as between our roles as compliance documentation authors, as well as a different role as actually trying to bring value to our clients and lowering their energy bills. Third topic, I was going to show you, like, I've heard a lot of consultants out there. They're like plugging and chugging. They're like pressing play, and they iterate on their models, and they just spend all day, like, doing a 5-minute or 15-minute kind of chunking through these models. Whereas I have this other way that I set up 40 miles in advance, and I press play, and I go off surfing for a couple of hours, and then I come back. Everything's done. It's just like a much more efficient workflow. So I was gonna.
You don't have to rush that much. It's okay.
Yeah. Well, I can show you later.
Like a third of us are energy modelers.
Okay.
You're not speaking to strangers on this topic, so really.
So I've got the command line syntax that Ken Nedler showed me, and I've got a little bit of as well as if you know batch the command line tools, or you can download some from the internet. You can just you create your own command line batch files, which I've broken out in my slides. Again, I can show you. It might be more interesting if I could show you the energy consultants out there later, if you're interested in looking at that. Last one I wanted to talk about directly was actually how when you've got an energy modeling file. I think hopefully you've seen yesterday that part of the open source nature of CBECC-Res, as well as CBECC-Com, is the info file is a human readable text document. Not that unless you really opened it with a text editor, you might not have known that. But you can look through and you're like, oh, I could make this, if I were really clever about it, in a Word in a Word document, if we're just really good about the syntax. What I've done with it for my own tools is I've built my own spreadsheet so it's much easier to navigate around a spreadsheet for my work, because I know Excel pretty well, and then have that produce an input file. And just demonstrating that you guys can create your own tools. I've already included in the collateral I've sent to Sean, like my window schedule editor, so you can do edit all your windows and label them and do all the shading stuff, which is really important for both compliance as well as ZNE analysis, but not have to spend hours click, shade, or manually enter these numbers that you can sort of really copy and paste much more powerfully through the text editing. The idea that you could build your own tools was, from what I heard from Martha Brooke, exactly the point of why she took it into the public realm and took it out of sort of these locked, closed source code energy software providers. So I can show you that later on. And
which slide, Jeff?
This is, I don't have my numbers on here. I'm on 20. And that's actually it. I think I've been about 10 minutes. So I want to be quick. Talk to me later. Oh, yeah. Last appendix, another separate project I've been doing all together.
Stay for questions. Don't just wait.
Is I've been trying to figure out how to do data sonification, meaning you look at the grid, you look at temperature data. It's like, that's a sine wave. I can make music out of that. And you can hear all the textures on that. And figuring out how, there are lots of ways you can turn this data into music, like music of the spheres. But I can show you some really quick ways you can listen to your data. It's just a fun little side project.
Wow, does it give you things? I mean, do you hear coarseness or does pitch help? Or
Mostly, without some massaging, you hear different kinds of static. And static, I love static. I got Merzbow, he's a noise artist,
For years, my wife took her temperature every day, and then I asked my best friend and my brother-in-law, who are both professional musicians, to turn it into a song, and each of them did their own version.
Right.
And it was wonderful.
Yeah.
Thing to listen to. It was and it's kind of pretty. And
yeah. So you can do that because you're just producing lots of data, and it's kind of sinusoidal. A lot of it is. So yeah, you should be able to listen to it. Of course, TDV sounds like a goose fart, but because it's and then silence. But that's what the ISO deals with, goose farts. That's the world, man. I don't. Okay, questions? Yeah.
So we work with a lot of affordable housing clients, so they're on the low end of the income spectrum.
Yeah.
Sounds like I want to hear some stories from you about those that on the other end of the income spectrum. But we find some of the residents really care about energy efficiency and they use low amounts of energy. Others don't care and use high amounts.
Yeah.
Is it the same phenomenon in the high end, or are you seeing
Yeah.
it?
I would say the same thing. I would say, I think to summarize it, I tend to see, of course, that insulation and the kinds of things that are regulated in Title 24 for us our energy consulting work is actually a minority of the energy use for most of the projects I work on, and it's really problematic and disconcerting to me. Because I don't have a framework for how to discourage those loads. The framework or AV systems, the amount of they have a server farm in their basement. The only real problem I have with it is deeply unproductive in terms of what they're getting out of it. It's you could do that with a Chromecast, man, and you spend $200,000 on paying consultants to build you your custom movie theater thing that isn't actually giving you that much benefit. But I don't know. That's I have sometimes a lot of opportunity to go through some of our past projects, and I hear some of the problems, and I oh man, These aren't problems for the rest of us, mostly because we just go to Best Buy and we find the off-the-shelf technology. But to answer your question, I think a little more in a broader way, I do see as a challenge for us and the industry is to really put the human back at the center of the energy system, because, or not to appropriate the NRA slogan, people use energy, buildings don't inherently use energy. So I want to
better use of that framing.
yeah, for sure. And to really put them in control of their energy use, so that all energy use is discretionary. It's not just, hey, there's a thermostat in the model and says it's 68 during the heating season and 74 in the cooling season. We really should be able to say, any house, no matter how big or how small, can be mostly off, and we're just using energy services as we see fit, and the rest of the time it's off. And that's where a lot of architecture comes into designing, like when you come, an easy way, you can turn on the lights if you even need it to begin with, and then if you forget to turn them off on the way out, they're automatically off. So that's an occupancy sensor. That's still not common in my world. Well,
have you had the opportunity to deploy monitoring systems that validate the in-depth modeling and predictions that are made?
Yes, and I would say, generally speaking, the modeling or the monitoring systems we have deployed just show us as to why our energy models are wrong. That
what granular level or what brand are you using?
And we've used eGauge, we've used TED. I mean, these are pretty coarse analyses. We've done there was a company that is now defunct called Agile Waves. What I'm seeing is the models are pretty good at the thermal, like assuming a standard human. None of our people living in our houses are average people. Everyone's exceptional, right? So that's the problem with our models, is we've taken the human out of it, and people are weird. People mess up. As you've experienced, some people use a lot of energy, in which case now they're going to not be space heating much. They're going to be cooling because there's a lot of internal heat gains in that envelope. Some people are going to be heating a lot because they leave the window open because there's not fresh air provided, and they feel stuffy in there, so they run the heat with the window open. There's a logic to it.
Yeah. The topic of the presentation is unlocking CBECC-Res. Have you tried unlocking the battery module yet?
Yes.
Any initial results or opinions?
They make sense to me. Actually, I can show you later, if you'd like. And I guess, so the question being, have I unlocked it? Yes, I have, and it seems to show like good results. Huge impact on TDV kind of consumption. Sort of playing on yesterday's topic about thermal storage, but as a strategy to actually allowing people to take compliance credit, for batteries, even though they're not cheap, but they, at least by the modeling, work pretty well. And yeah.
So when you do a research version, you can use that for compliance?
No.
Okay.
No. You're doing it because you're doing the research run for bringing value to your clients. So an example might be actually for build a green, for green point rated. You need to actually look at your loads. Traditionally, for like those build a green projects, you'd have to have an Econ 1 or Econ 2 report. CBECC-Res doesn't have those out of the box. You can create your own, and I think most consultants don't know how to do it, but actually you can create your own, have much better granular data with those results, and be able to like fulfill green building programs and demonstrate and segregate between like lights and plug loads and all those the elements of energy use. So yeah, for compliance, this is, that's up to the CEC.
On each of these runs, do you change just one variable at a time?
Yes, that's generally how I approach it. Because if you can set up, this is for the batch runs, right? Mm-hmm. If you're running a batch, you want to like get as many, sort of change one thing, sort of analyze the result, I actually do two approaches on 2 dimensions. One is the a la carte, like, okay, we're going to just upgrade this insulation. We're going to just upgrade, the HVAC. We're going to just upgrade off of a baseline something else. And then I'll do another set of runs where I add them up. Just to, for the most part, like, depending on the kind of energy efficiency measure, some should be clearly additive, but when you're feeding back between insulation and HVAC, sometimes there's synergistic effects or anti-synergistic effects. So,
I have another question.
sure.
But we're on time.
Oh, all right. It's all good. We can chat later.
Yeah.
It's all good.
I love it. Thank you, Luke.
Thank you.
So, if you all can bring up Clay Johnson's presentation.
So I don't have the original flash drive.
There's 3 flash drives going around with my presentation on it.
But I actually, to correct that, I'm going to send around 5 more presentations.